friends, today I'm going to solve LeetCode problem number 207, course schedule. In this problem we are given total number of courses, num courses, which are leveled from 0 to num courses minus 1. We are also given an array prerequisites where each element in the array is also an array with 2 elements, and here AI is the course that we should take to take the course actually no, where BI is the course we have to take in order to take the course AI. So basically, to take the course AI, we need to first take the course BI. So for example, here we are given the pair 0 1, which indicates that to take 0 we have to first take 1, and here we need to return true if we could finish all the courses, otherwise we return false. Now let's see how is this actually working. So let's take an example. Let's take an example where we have an array of prerequisites 1 0 and 0 1. All right, so we are going to take this example. Here the number of courses is equals to 2. Now we can see that 1 is dependent on 0, which means that to take the course 1 we need to take the course 0, right? So to take the course 1 we need to take the course 0. So basically 1 is dependent on 0. Now here 0 is also dependent on 1, which means that to take the course 1 we need to first take the course to take the course 0 we need to first take the course 1. So here what's happening is we are getting a cycle. Since we are getting a cycle, which means that we can never complete this course, because for 1 we have to first take 0, but for first to take 0 we have to first take 1. So there is no solution for this, right? Which one would you take first? So in this case we return false. Okay, so this is how we are actually going to identify which course to solve by using graph, and by identifying if the graph consists of cycle or not. So here we are given an example, and in this example we are given the course 1 depends on course 2, 2 depends on 3, and so on. So from this example we are going to create an adjacency matrix. So for this example here, I took this example from one of the test cases that I created myself. So the number of courses here is equals to 4, because the maximum value, okay, this is not actually the example, sorry, this so here we are going to take this example and we are going to see how to solve this using graph. So the number of courses here is equals to 4, because we have courses starting from 0 to 3. So now we need to create an adjacency matrix. Adjacency matrix would be such that to take the course 0, which other courses should we take? So for 0 we need to first take the course 1, right? So for 0 we need to take the course 1, and for course 1 which other courses do we need to take? Well, there are none, so it would be empty. For course 2 we need to take course 1, and next for course 3 we need to take the course 0. So for 3 we need to take the course 0, and for 3 again we need to take the course 2. So we are going to add one more element here, which is 2. All right, so this is our adjacency matrix, and using this adjacency matrix we are going to now find a cycle. So what are we going to do is, let's first start from 0. So we are going to start our iteration from 0, and from 0 we are going to look at each of its children, each of its neighbor. It only has one neighbor, so at this neighbor we are now going to check is there any cycle that it is forming. So from 1 where are we reaching? We are not reaching anywhere, it's empty. So basically from 0 to 1 there is no cycle, right? Now since we have traversed the children that it has the neighbors, so we now are done with 0 and 1. 0 and 1 doesn't form a cycle. So next, when we are going to check 1, we don't actually need to check it, because like we already did it while we were checking for 0, because from 0 we went to 1, and from 1 we did not find any cycle, right? So we don't have to even check it independently here. So for that, what we could do is we could create a visited set where we are going to keep track of all the nodes that we have visited, and if the node has already been visited, we don't need to visit here or revisit here again while we are iterating. So now that we have visited 1 and 2, 0 and 1, we visit the node 2. So for node 2, it's dependent on 1, right? So node 2 will also point towards 1. So from 2 we are going to 1, and 2 is already, 1 is already visited, and we know that from 1 we are not getting any cycle. So we just know that for 2 also we don't have any cycle. So if a node is already been visited, we know that there is no cycle, so we are just going to return back. Now next for 3, so from 3 we are going to 0. So from 3 we are going to 0, and 0 is also in visited. We have already visited 0, 1 and 2, right? So 0 is already in visited, so we know that 3, this will not form a cycle. Next 3 also points to 2. So for 2 is also already been visited, and we know that it's not going to form a cycle. So basically we are able to complete all the courses here. Now let's modify this example here. So for example, we have one more node which is equals to 4, and 4 is dependent on dependent on 1. Okay, 4 is dependent on 1. Okay, 4 is dependent on 3. All right, 4 is dependent on 3, and 2 is also dependent on 4, right? So this is what we have. So if this is the case, then what will our graph look like? Let's create our graph. So let us start from 0 again. So from 0 we need to take the course 1, so we take the course 1, and now in our visited set, what do we have? We have 0 and 1, and we don't have a cycle yet. And now for 2 we need to take 1. So for 2 we take 1, and we know that 1 is already visited, so it is not creating a cycle. So next we do the same for 4. So from 2 we also visit 4, and now for 4 we have 3. So for 4 we need to take the course 3, right? And we need to add these nodes to our visited nodes. So we have already visited 4, 2, 4 and 3. Okay, now for 3 we need to take the course 0. So what's happening here is we need to take the course 0, and basically it will go this way. Okay, I'm just going to create and put an array so that we are able to see that there is no cycle. So what's happening here is from 3 we are reaching to 0, and we know that 0 is already in visited, so it's not going to create a cycle. And to verify, we can also look at this. So from 0 we are reaching 1, but from 1 we are not going anywhere, right? We are starting from 2, 4, 3 and 0, and then it ends at 1, so it's not a cycle. Now let's look at another one. So from 3 we have 0, we also have 2, right? So from 3 we are also visiting 2. Now while we are visiting 2 from 3, it is also in the visited array. So basically what that should mean is that it should not create a cycle, but it's actually creating a cycle. So from 3 to 2 we can go to 2 to 4, 4 to 3, and then we would be stuck in a cycle. So basically this means that this visited set is not enough, so we need to create one more set, which is a stack. We could also call this as the path. Okay, I'm just going to call this as our current path. So in our current path, what did we do? We were traversing node 2, right? So we would have node 2, 4. From 2 we, okay, let me just redo for 2. Okay, so yeah, so we have 0 and 1. Now we need node 2. So for 2 we have the and we also need to modify this one. Okay, so from 2 we need to go to, we have a connection to 1, right? A graph to 1. So what do we have here is, now in our current path, that is our current path that we are following, we have 2, and then we also have 1. So we have both 2 and 1, and from 1 we know that it's already visited, so it's not creating a cycle here. Next, we are now going to check the next neighbor. So while we are checking the next neighbor, this will not be our path. Now our path will be from 2 to 4, right? So we delete 1 from here and we add 4 to this one, and now from 4 here we are going to 3. So from 4 we are going to 3, so to our path now we also have 3. Also, we need to keep updating our visited array, so we are going to add all the nodes that we have already visited, which are 0, 1, 2, 3, 4, right? So these are in our visited set. Now from 4 we visited 3. Now from 3 we are able to visit 0. So we first check, is 0 in our current path? No, right? So that means that it's not creating a cycle, so we visit 0. Okay, next, once we have visited 0, we know that it's in the visited list. So what we do is, we just know that it's not creating a cycle. So next we move to its another neighbor of 3, which is 2. So now the path is going to change from 3. Now we are going to 2, right? So from 3 we are going to 2. So our path is from 2, 4, 3, 2 again. So here, as you see, we are again adding 2 into our current path. Our current path already had the value 2, but we are again trying to add 2. So if our current path already has the value 2, then adding the same value means that we are creating a cycle. So since our current path is creating a cycle, that is when we know that we are not going to be able to solve all the be able to take all the courses. So this current path gives us the idea if there is a loop or not. Okay, if there is a loop or not, if there is a cycle or not. And this visited is used to see to prevent repetitive calculation. That is because we have already visited node 1, and like for example, there could be multiple nodes, multiple levels here for 1, and if we are not taking this visited set, we are not creating this, then every time we are reaching node 0, we need to check if we are creating cycle from these edges or not. So since we already know that, because once we have done the calculation, we don't need to do the same calculation again, right? We can just use the previous result. So that's why we are using this visited set. So I hope that now you understand the logic. What we are doing is, we are creating an adjacency matrix using our prerequisite set, our prerequisite array. We are creating a current path, which is a set, and a visited set, and based on these we are performing our calculation. And for our calculation, we are actually traversing one node at a time, right? From over its depth. So that is a DFS approach. So let's try to solve this now. So what we are going to do is we are first going to create our array. So adjacency matrix equals new array of length number of courses, fill it with a value, and then map each value to an array. So it's an array of array, it's a matrix. Now for let pq of prerequisites. Now for each of the prerequisites, adjacency matrix of p push q. So since p depends on q right here, 0 depends on 1, right? So for the index 0 we are adding the value 1, so that's what we are doing. For the index p we are adding the value q. For index p at adjacency matrix we are adding the value q, right? What's wrong? Okay, adj adjacency matrix, and this will create our adjacency matrix. Now once we have our adjacency matrix, we are going to create visited list, and we are going to create current path list or set. Okay, so both of these are set. Also, let's first create our DFS solution. So equals to a function of node, and we need to check what we need to check here. We are first checking if the current node that we are traversing is in the current path or not, right? And after that we check if it is in current visited node or not. So if current path that has a node, then we return false, because that time it's creating a cycle. Else if visited has a node, then we return true, because we would know that we have already visited this node and there were no cycle that we encountered while we visited that. So okay, let us put it over here, as t visited. All right, so now that we have checked for both of these, once we have checked, now we start traversing over the node. So we need to add these to our current path. So current path dot add the node and visited dot add our node. Okay, and then we are going to perform DFS over all of its children, right? So for let neighbor of adjacency matrix of the node, we are going to perform DFS if DFS of neighbor, that is if we get a false, which means that we are getting a cycle. So when we return a false, and this not sign would make it a true, and if it is true, then we are going to return false, which means that we found a cycle. Else what are we going to do is if not, we just keep continuing the DFS. And then at the end, once we have traversed all of its neighbor, we have like at the end of the DFS, we need to delete from the current path the node, because what we are doing here is in case of 0 and 1, okay, let's suppose we have one more 5. So first we will traverse 0 and 1. So from 0 we traverse 1, and from 1 we do have nowhere to go. So next what we do is we traverse 5, right? So this will return true, and then once this has returned true, we traverse 5, and 5 also returns true, and then now it has nowhere to go. So yeah, we are actually going to delete the path from here, delete from the path here, because once we are doing the DFS from 1, we are removing 1, and then we are going to its next neighbor. So before going to its next neighbor, we need to delete this from the current path, right? That is what we are doing here. And if everything worked fine, if all of its children are traversed, that is when we know that it is not creating a cycle, and we return a true. Okay, and then finally what are we doing is for each of the nodes in the graph, we are performing the DFS. So for I equals to 0, I is less than the number of courses, okay, I plus plus, and if DFS is false, then we just return false. Let's stop our execution, else we keep on performing our DFS, and if everything works fine, then we finally return a true. Okay, I think that this solution is now complete. Let's try to run it and see if it works. Okay, so has is not a function. Okay, instead of this, let's use new set object, because has is the function of the set object. All right. Oh, so we are getting a false here. So we are always getting a false. And why are we getting always false? So we are creating the set and the current path, and okay, let's take this example. So we have 1 which is dependent in 0, and 0 is not dependent on any. So when we start from 0, okay, our adjacency matrix here would be like this. So for 0 index, we'll have an empty array, and for index 1, it depends on the course 0. Okay, so we are starting from 0 and we perform DFS on 0. So we go here, and then the current path is currently empty, so it doesn't has the node. Also Vista doesn't has the node, so now we add to our current path the node 0. Okay, so now our current path has the node 0, and our visited also has the node 0. Okay, so we added 0 to both current path and node, and now we are trying to iterate over the neighbors of 0, but we do not have any, right? So this won't be executed, and it's going to return true. So here it returned true, which means that here we received true of not of true is false, so this won't be executed here. And next we will move on to the next course, which is equals to 1, right? Now okay, so the problem here is that we are trying to execute 1, but in our current path we already have 0. So 0 should not be here, so we are doing something wrong here. Yeah, before returning from here we actually need to delete from the current path. Okay, let's try to run this now. Okay, it's working, but do we need this here? Let's try to comment this and run. Yeah, so I don't think we need this here. Yeah, so let's submit this. Awesome. Yeah, so why do we not need this here? The reason for that is because like we are performing a DFS, so once we are performing DFS we are only we are going to the end, and after we reach the end node, that is the node which without any children, this won't be executed. So we need to actually perform this to remove the last node from the current node and current path, and then return true, and then the next in once it has returned true, it will reach here and then it will check the next neighbor. So basically this is executed here right before we execute the next with the next neighbor, so that is why we don't need it here. Now, okay, talking about the time complexity, we are creating an adjacency matrix of length nums course, right? So that is, if this is n, then that would be O of n time complexity, and we are again iterating over each of the prerequisites. So if there are m number of prerequisites, then that would be O of n plus m. Also the space would be O of m plus n, because we are taking O of n number of space, and here we are also taking O of m number of spaces by pushing each of the elements in the prerequisites. Also here in the visited and current path, we would be using O of n maximum of O of n number of spaces. So yeah, that is the time and space complexity of this solution. Hope you liked my solution. Let me know in the comments down below.